All right, here we go with some additional examples applying the theorems that we talked about in the last video. Now again, these aren't necessary for you to watch more examples, but I really like to see the different ways that these theorems now just play kind of like a puzzle. We're putting it all together, whether it's the central angle, the inscribed angle, the idea that triangles, the sum of their interior adds to 180 degrees. All of these are going to come together in a beautiful way to help us find these different pieces inside the circle. So I'm just going to look through a bunch of these examples. Again, you could probably solve them in different ways. I would give them a go first, pause the video, give it your best shot, and then see if we can go through it together. So these first ones, we're just applying circle properties to find the different variables. So again, looking at this first one, this just kind of puts it all together. Remember that if we have an arc related to a central angle, if that's 120 degrees, this guy's also 120 degrees. These two angles make a straight line. So they make 180 degrees altogether. So if that's 120, then we subtract that from 180, and that leaves us with x as 60 degrees. So applying both of those together. Number 11 looks a little more tricky. But again, we just work with what we know, and then we build from there. So one thing you can do is just look at the little shapes that are inside of here. So notice there's a triangle. See this triangle? Oops, I tried. This is a radius. This is a radius. That guy's isosceles, just like in the last video. And if we look at an isosceles triangle, if this angle is 49 degrees, then this one must also be 49 degrees. So that's one way we can look at it to start filling that in, and then that's a triangle. So we know that if two of the angles, right, are 49 degrees, and all three of them need to add to 180, then we just subtract that 49 and that 49, and we end up with C as 82. Now notice we're just building off of that. If that's 82 degrees, then we know that C and E are linear pairs. So 180 minus the 82, right, is that 98 degrees that would be right there. Pretty cool. Now we look at this triangle. Yeah, see this guy? We're looking at this one. Again, using a triangle, we know that B plus D, right, plus 98 needs to equal 180 degrees. Well, B and D have to be the same thing. So really, if we just take 180, we subtract 98. Sorry, that would be equal to 82. Then we just divide that up evenly into those base angles. So 82 divided by 2 is 41 and 41. So these actually both have to be 41 because that's also an isosceles triangle. So we've now figured out, right, that A is 49 degrees, B is 41 degrees, C is 82 degrees, D is 41 degrees, and E is equal to 98 degrees. Now, that's my favorite way to look at it, just using triangles. Triangles are awesome. And the other way you can look at this, just really quickly, is you can look at the intercepted angles and arcs. So notice here, this guy right here is 49 degrees, this angle, which means this arc out here, I know it didn't ask us to find the arc, but essentially the arc would be 98 degrees. Now notice this central angle right here is subtending that same arc. So this guy, again, we already looked at that, but would also need to be the 98 degrees. Does that make sense? Now this right here is creating a semicircle. So if that's 98 degrees, right, then we're looking at this side being 82 degrees. And if that's 82 degrees, then his intercepted angle over here, angle D, is half of that. So that's 41 degrees. That doesn't say 41. Yikes. So lots of different ways you can look at it, and then again you could use that 98 degrees to help you find C. We know that this is a right angle because this is a diameter in the circle right here. So that one must be 90 degrees, so we could figure out that that's 49 degrees. Again, lots of different ways to look at it. There's that one. Jumping down, number 12. This one uses a triangle and an inscribed quadrilateral. So let's first look at the triangle because we're good with those. Notice the triangle, we've got 40 and 70 already in there. We know that a triangle needs to add all the way to 180. So if we want to find this one, we just take 180 and we subtract out 70, we subtract out 40, and that leaves us with 70 degrees. Now again, it didn't ask us to find that, but that's how you do puzzles sometimes. We want to find this one, but remember these ones add to 180. So if C needs to be found and A is 70, Then we just take 180, subtract 70, and a little c would be equal to 110 degrees. All right, looking at 13. This one you have your polygon and your inscribed angles there. Remember that relationship? We can use both. So first of all, I can find A. If this is 87 degrees and these two need to add to 180, then A is just going to be whatever 180 subtract 87 is. So we take that, right, we subtract, and A would be equal to 93 degrees. So we're good with that. This is 93 degrees. Then looking at, erasing that, B. If I want to find B, notice that 78 degrees, I'm going to highlight this, is an inscribed angle for this whole arc. Not just B, but actually it goes from here, right, to here. So if that's 78 degrees, remember its arc is double that. So 78 times 2, this whole thing out here should be 156 degrees. So you've already got 36 degrees right here. So B would be whatever's left of that. So 156 minus the 36, B is equal to 120 degrees. Now we can use that same logic going the other direction. I'm going to erase this just so it's not confusing. If we're looking now at this guy, right, in this angle, and that one was 93, oops, erased it, then we know that 93 times 2, or double that, is this arc out here, this whole thing. Again, you got to go from where it starts to where it ends on the angle. That guy's 186, because that's double the 93 angle. And 186 is that whole thing, but you've already got 36 right there, so you just subtract out the 36, and C must be equal to 150 degrees. So on this one, A was 93 degrees, B was equal to 120, and C is 150. All right, last crazy one, and then just a couple basic questions asked in the way that you'll see on your quiz. Number 14 looks a little bit crazy, but really, again, they're just inscribed angles. So we're going to look at these different pieces. You'll notice, and I'll try and highlight and then erase, but this guy right here is 26 degrees, which means that this one right here, I know it doesn't look like maybe it's the same, but it's creating that same arc. So notice they're both just creating this arc. So if that angle is 26 degrees, then C must also be 26 degrees, right? Those would be equivalent. So I'm going to write it off to the side so that I don't lose that. Then we continue and we see if we can find another part. So those two were the same, right? This one's 26 degrees. You'll notice that this one is 35 degrees, going the other direction, so it's creating this arc out here. Notice there's other ones also creating that. So if you look at A, this guy right here, he has those same endpoints, creating that same arc. So A must also be 35 degrees, as well as B over here. So notice he has the same endpoints here and here, also 35 degrees. So A must be 35 degrees, and B is also 35 degrees. Now D is the only one that I haven't found yet. D is not at the center, and it's just hanging out there. So maybe the easiest way for me to do this one is to look at either this triangle or this triangle, right? So these two should be equal right here. This one was 11. We found out B is 35 degrees, so this angle is going to be pretty easy to find. And then I know that those angles that are across from each other, they're called vertical angles, should be equal. So if we take 180, we subtract 35, we subtract 11, we know that this is 134. So D would be equal to 134 degrees. Okay. All right, lastly, a few of these questions that'll look similar on your quiz. So this says use each provided diagram to find the indicated arcs or angle measures. So on this first one, determine the measure of arc length PQ. So PQ, and I'm going to highlight it so that we know where it's at, is this guy right here. Now again, we know this angle is 90 degrees. Remember, we know this is 120, and this is a diameter because it's going through the center right there. So that means that PQ right here, if this is 120 and this whole thing has to make a semicircle, this would have to then be whatever 180 minus 20 is, which is 60 degrees. So if we're talking about arc length PQ, that's 60 degrees. Now, this one's asking for the angle QRP. Now, remember when we find angles, we start with that first letter and we work all the way through the letters till we create an angle. So we're starting at Q, then to R, then to P. So it looks like it created this angle right here. Again, if this is 60 degrees, then that inscribed angle is half of that. So this is 30 degrees. Okay. Number 16, determine the measure of DZE. So DZE is D to Z to E. It's exactly where that question mark is. And again, using the same logic we just did, if it's creating this arc of 108, then we take 108 and we divide that in half, and this would be 54 degrees. Now notice that the next one it asks for is E to C to D, so E to C to D. Those two are creating the same arc. So this is also 54 degrees. All right, lastly, determine the measure of arc LMJ. So we're going from L to M to J, right? We already know that the other two pieces are 41 and 69, and remember all the way around has to add to 360. So if we take 360 and we subtract out 41 and 69, then that tells us that this whole thing out here must be 250 degrees. So arc LMJ is 250 degrees. The next one says identify one minor arc. So you get to choose on this one. Again, remember minor arcs are just less than 180. So you could either do JK right here or you could do LK. It doesn't matter. So let's say we do LK or KL. That's one. That's a minor arc. Lastly, how might you determine what measures an inscribed angle with intercepted arc JK would be? I'm going to erase these really quick. So it's saying if we had JK here, right, we know that that's 41 degrees. How would we find an inscribed angle? Sorry, bad language there. Right? And we know that it's just half of that central angle. So if that's 41, then we take 41 and we divide by 2. So in this case, we would just say, right, that you would divide the central angle by 2. So that angle would be 20.5 degrees. All right, there's some fun examples. Again, you're going to see a few like this on your worksheet, some on your quiz. So just be comfortable with those theorems going back and forth. And don't be afraid to highlight, or like I've been doing, drawing the angles so that you can see where the arcs are. I use squiggly lines just to help me see the arcs. If you need to use color, you can do that as well. But just kind of have fun with it. There's a lot of freedom in mathematics. I feel like when you're doing geometry, you just have to follow the guidelines surrounding that. So have some fun with it.